So we have this slope, right? And we want to know like how far up. So the skier starts here, right? And then they end up here. So the initial velocity is going to be what?
I have no idea.
Okay, so that's how fast, the initial velocity is going to be how fast that they start going.
Okay.
So it's going to be like the beginning speed.
Okay.
So if we look at like, oh, something came up.
Oh, that's the book.
Oh, gotcha.
Okay. Yeah, it took forever to load.
Oh, no worries.
So this is the book that we have in it.
Oh, okay, I see. That's cool. Okay, so skier traveling. So it tells us at 39.2 meters per second, right?
Mm-hmm.
So we know.
So that's what that is.
Yeah. Yep. So that's how fast they're going to be going initially,
Okay.
and then the final speed is going to be what? Do we know what that is?
It's not given.
Yeah, it's not given. So let's read and see if we can like decide what it's going to be. Counters 18-degree slope. So how far up the slope does he go? So because of that, we're going to say his final is just going to be 0.
Okay.
So
It stopped, right?
yeah, exactly. So 0 meters per second. Okay, so we're going to ignore friction on this. So this is the information that we're given, right?
Mm-hmm.
So next we're going to draw a free body diagram on the skier
Okay.
to find out like the forces.
And that was what we had to do for the group work, and I don't understand that either. So that
Okay.
was something that I wanted to.
Okay, cool. Yeah, let's go over that. So I'm going to redraw it over here. So we got
Okay.
this slope, 18 degrees, and we got the skier here. I'm just going to, this is just going to be the skier.
Okay, that's fine.
So what kind of forces are acting on the skier?
So gravity.
Gravity.
9.8.
Yep, and that's me going what way? What
Down.
direction? Yep, straight down, exactly.
That's the only one I know.
Okay.
So.
Yeah, so this is going to be, it's going to be 9.8. So we're just going to say this is mass times gravity.
Okay, which equals force, right?
Yep, yeah, which is a force. Yep, exactly. So now we also have a normal force, right? So do you know what normal force is? Or did you talk about that?
No, I don't know what that is.
Okay, so a normal force, I'll just draw something a little simpler right here.
Okay.
So we have a block, right? So this block has gravity. So it has gravity pulling down on it. A normal force is a force that basically like goes perpendicular with the surface it's on that's going to counteract
Okay.
like the gravitational force. So a normal force, we indicate it like that, F sub n. This force is going to be, this force comes from Newton's third laws. So, which basically says that like every force that interacts with something has an equal and opposite force, right? So gravity pulls down on this block. The table is going to push back up on the block just as equally as gravity pulls down on it.
Okay, so the hill's going to be what is pushing against the skier.
Yeah, exactly. And so since it's a normal force, we're going to draw it perpendicular to the surface. So it's going to look like that.
Okay.
Yep. Yep, and those are the only forces we have, right? Because normally we would have a frictional force that's going to oppose it,
Okay.
but we're ignoring friction in this case, so we don't have to worry about friction. So really all we have is normal force and gravity pulling on him, or pulling on the skier. So I'm actually going to write this over here. Because what we're going to do is anytime we deal with a slope, so normally we have like our x-axis, right, and y-axis. So y-axis, x-axis. Anytime you deal with the slope, we're going to tilt the axis. So the x-axis goes along with the slope.
Okay.
And you'll see in a minute why that's really helpful. So X and Y. And so when we look at different forces, we only want to look at forces that are in the same, they either go the same direction or the complete opposite direction. We don't want to deal with forces that are like skewed like this, if that like makes sense.
Mm-hmm.
So we want to split this gravitational force using this as the hypotenuse into like a triangle of X and Y. So we're going to have, this is going to be the force of gravity in the Y direction. And we're going to split it like this. So we're going to have the force of gravity in the X direction. So then this forms a right triangle right here. And this angle between the force of gravity in the Y direction and the actual like pull of gravity is going to be 18. It's going to be the same as the slope. Yep. So what we want to do is we want to figure out basically, so we know that the gravity is going to be pulling down at 9.8 meters per second squared, right? So now we have this. So we want to find out how much gravity pulls down in the X direction. So we have one side of a triangle, we have the hypotenuse of it, and we have the angle. Let me actually. So how are we going to find this side?
This side.
Mm-hmm. So we're looking
Can't
at.
remember which one it is.
So it's going to be sine.
Sine.
Yeah. So we're looking at the opposite side. So that's going to be sine.
Okay.
Yep. So we're going to set it up like this. We're going to say sine of 18 degrees is going to equal the opposite side, so gravity in the X direction, divided by the hypotenuse, which is just gravity. So now we're going to solve for, let me erase this.
Let me pull this out of the calculator.
Okay, so now I would just solve for this G right here.
Mhm.
Yeah, it's going to be, well, what did you get for it?
Negative 7.4.
Okay. And units is going to be, since it's an acceleration, so what are the units on this? So
Is it kilometers?
So it's going to be, well, we'll just use meters.
Okay.
So meters, it's just going to be meters per second squared since it's
per
acceleration.
second, okay.
Yep. So this is why we found this is convenient for us because this, if you notice, it's pointing down the slope.
Mhm.
So her velocity is going up the slope, and she now has an acceleration going down the slope at negative 7.4 meters per second. So that's some pretty good information, and we want to know. Yep, we want to know the distance. So from here, do you have any ideas about what we could do from here?
I think that was the last stuff that we did on our last test.
Yeah.
I bombed that one.
Okay.
So
Okay, that's okay.
that's why I contacted you.
Yeah. So we're gonna we have a list of what we know, right?
Mhm.
So we're gonna use those kinematic equations. Do you remember those three equations that you talked about? So I'll write these out. These are the kinematic equations. So
Oh yeah.
yeah, remember these? So we have our final initial starting points, initial velocity times time plus 1/2 acceleration times time squared.
Yeah.
Yep. AT.
because I studied those right before I'd taken the test.
Oh, yeah?
And I wrote them on the back of the
Okay,
test.
yeah.
So, yeah.
Okay, cool. So you remember these then?
Mm-hmm.
Okay, so let's just go through real quick, right? So we have an initial velocity.
Mm-hmm.
We have a final velocity. We have acceleration. And we're looking for the distance. So which one of these would you use? Like, which one would be good to use to solve for the distance based on the information we have?
So we have the initial.
Mm-hmm.
So it's not going to be the 1/2 one, right? Because we need the initial distance.
Yep, so it won't be that one. Yeah. So it won't be this one. Because also we don't know time, right?
Yeah, so it's not. So it's going to be the last one.
Yep, exactly. Yep. It's going to be the last one. So we're going to plug everything in here and solve for it. So for our final is going to be 0. Our initial is going to be the 39.2 squared. Let me write in units. Squared. From there, we just do the algebra. Right, so we'll square this, bring it to the other side. So I'll have a negative 39.2 squared. Divide everything. Yep, and that will get us our distance that we're looking for.
So then 103.83.
Okay. And that's the distance that the person goes up.
Okay.
Yeah. So that one's kind of tricky because we have to use forces over here, right?
Mm-hmm.
And then, right here, to get acceleration. And then we have to go back to our kinematics, the stuff that you learned, in the first couple chapters.
Mm-hmm.
So it kind of uses both. So we can't forget these. We have to remember them, which unfortunately,
You have to build on.
Yeah. So you can't forget those, but you won't use them as much, but still remember that they're still there, so.